Hey guys, welcome back. We are right now dealing with the one of the most demanding topic, and that is called as ion detection, or it is called as salt detection, salt identification, ion identification. Different names can be given to the same topic. So here in this topic, there is a sheet, there is a page in front of you. This page is luckily now available. Okay, now means for the last 2 years it is now available. Rather, I should say it very clearly. Last year was the first year when it was available to the students of 5070 and 0620 as well. Okay, so from now on, from that year onward, this will be the part of your ATP paper. But what should we do for this sheet? Should we memorize this sheet or not? If it is available, then why we have to memorize it? There is a problem that in MCQ paper, when there will be a question related to salt analysis or salt identification, this sheet will not be available in the MCQ paper, as well as it will not be available in the theory papers for both 5070 and 0620. So it is my suggestion to memorize this sheet thoroughly, so that you people may not have to waste your time in ATP paper as well by turning the pages again and again, and it will be helpful for you in theory paper and in MCQ paper as well. So this is as it is required. So it is very clearly ask you to keep this thing in your mind. And number 2 point is this, that now the exam date sheet is uploaded in November for current coming CIs. You people might know this thing, that if the starting papers are of theory papers, the central papers are of ATP papers, and the final exams are of MCQ papers. So ATP paper is sandwiched between the two. So it is really important to keep this sheet in your mind. It will not take a very longer interval of time for you to memorize it, and it is not an impossible target that to keep this sheet in your mind. The students before 2 years or 1 year before, they have to keep this thing in their mind for ATP paper as well. So it is just giving you a relief for ATP paper. And next point is this, that if you will keep this in your mind, it will increase your analytical abilities, evaluation abilities, some sort of judgment about a compound or about the ions present in that compound. So it will be quite helpful for you as well. Okay, one suggestion which I can make regarding this sheet memorization is this, that you people can make a practice of salt analysis. Okay, salt analysis worksheets are available online as well, and my past paper booklets are also available, topical ones there. The whole sheet for the salt analysis is separate. All the questions of salt analysis I have separated there. And there is one more point is this, that basically, if you are going to make the practice of this type of the questions again and again, then automatically this sheet will become part of your mind, and hence you people will learn this thing, how to implement this. Okay, so there are three columns. Before three columns, I would like to inform you some information, and that is, okay, let's move here. Okay, let's add a page here, and then we can write it down. Okay, so first of all, it is related to salt identification or ion identification. Salt analysis, or it is called as ion identification. Okay, so these are the two names for this method, for this topic. Okay, so here we can say that a salt, basically a salt is made up of two partners. Okay, two parts, and one of the part is a positive part, whereas the other part is a negative part. Okay, the positive part is called as cation, and the negative part is called as anion. All right, please, this is not anion and cation, this is cation and anion. All right, then number 2 point is this, that there will be separate tests for cation detection and separate tests for anion detection. For cation detection, two types of the substances are used. One of them is sodium hydroxide, whereas the other is ammonium hydroxide. Okay, ammonium hydroxide is also called as aqueous ammonia or ammonia solution, whereas the test of anions are different. Okay, And remember this thing, that if there is any gas produced in these tests, as a result of these tests, any gas is produced, we have to show its test and the observation related to that as well. We have to write that. Okay, there are certain flame tests as well given in these sheets. I'm going to show you, I'm going to share that sheet with you people as well. In that flame test, basically, just come here. Okay, let's see, there is a sheet there on the board, and the first part is containing the gases names along with their formulas and the test, along with the observation. Test and test results. Test means what we have performed, and the test results are our observation, which we can develop, which we can have by performing that test. In the last part of this page, you can see the flame test. Flame test is basically a test which we can observe by keeping that substance in the flame. So for example, if we will keep lithium ions, we cannot take lithium ions only. Obviously, lithium ions will be part of any compound, and we will stick that compound on an iron wire. And as a result of that, when we will keep that iron wire in the flame for like 5 minutes, as a result of that, we can observe 2 to 3 minutes, or 5 minutes is a sufficient time, when we will keep that wire in the flame by keeping any salt. For example, sodium color is golden, for example, or yellow here. By the way, let me let you know that golden and silver should not be written. If you are writing the color of gold, then you should write golden yellow or yellow golden. Okay, but yellow should be part of that. Okay, so please let me inform you how to perform the test for sodium chloride containing sodium ions. So we will take an iron wire, we will make a loop on one side of that iron wire. So for example, this is iron wire, and we are going to make a loop around one part, and as a result of that, we are going to immerse this iron wire in nitric acid, so that it may have some moisture type of a thingy on it, so that the salt may get stick with this. And now we are going to stick some salt on it, and keep this loop now in the flame, and we will observe yellow color. It will give us an indication that the salt which has been stuck with the loop is containing sodium ions. Okay, same is happening with the rest of all. This is the way to perform this test, and these are the colors which we can see after keeping this in the flame. And number 2 point is this, that these colors should be in your mind when you are solving theory paper and MCQ paper. These can be helpful to you. Okay, now how to understand this and how to implement that. Okay, basically these are the tests for anion. So if carbonate will be present, and if we are going to add our dilute acid, as a result of that, carbonate will produce carbon dioxide gas. What is the test for carbon dioxide? Obviously there will be an effervescence. What is the meaning of effervescence? This is the bubbling due to production of a gas. Okay, effervescence and carbon dioxide is produced, and a good student can write this thing, that will turn lime water milky. Okay, because this is a test of carbon dioxide, we already know. Okay, and there is a test for chloride, bromide, and iodide. Okay, let me take you to another page. Okay, so bete, there are some things which is called halide. Okay, so what is a halide? Let me tell you about that. Okay, so halogens are the elements of group number 7. Halogens. Okay, halogens are the elements of group number 7. So what are those? These are chloride, bromide. Okay, please, it is fluoride as well. Fluorine, chlorine, bromine, iodine, and astatine. Okay, so when all of these are going to gain one electron, as a result of that, they are going to make ion which is called as halide ion. Okay, halide ion. Okay, now what is the halide ion of your syllabus in salt detection? It is only chloride, bromide, and iodide. One more thing, that how to check these, we are going to add nitric acid along with silver nitrate. Okay, this is the important thing, that you should know that what we have added. Okay, when these two things will be added, if it is chloride, then it will give you white color precipitates with these two. If it is bromide, then it is going to give you cream color with these two, cream color precipitates with these two. And if it is iodide, then it is going to give you yellow color with these two substances, yellow precipitate. Okay, Many of the students are asking me generally that is that compulsory to write PPT or precipitate. It is good to write the whole word so that there may not be any confusion. But as PPT is written here in the notes given by Cambridge, so you can write PPT as well, but it is advised to write the complete word precipitate. Okay, so this is the test for the halide ions. For halide ions, what we are going to use silver nitrate and nitric acid. Okay, so for example, if we have silver nitrate and we want to detect silver nitrate, what should we add? We should add any of the halide. So from the halide we can detect, I'm spotlighting it, from the halide we can detect the presence of these, and from this, I mean to say silver nitrate, from silver nitrate we can detect these. So please keep this thing in your mind as well. Specifically in the latest exam, it is a dual type of analysis. So from one thing they can ask about the other, and from the other thing they can ask about the first one. Okay, so this is the dual type of analysis. Okay, now if I am taking you to the next page, you can see this thing that there is a test for sulfate. Okay, what is the test for sulfate? Guys, the formula of the sulfate ion is SO4 2 minus. Okay, what we have to add? We have to add barium nitrate, or you may say nitric acid and barium nitrate. Okay, barium nitrate and nitric acid will be added to it, and as a result of that, what will be formed? BaSO4, white color precipitate, white precipitate. Okay, so please, now the point is this, precipitate. Okay, now the point is this, they can ask about sulfate they can ask about sulfate from by adding barium into it, and they can ask about barium by adding sulfate into it. Okay, so the point is this, here is the issue. Sometimes the examiner is saying that one solution is taking, let's say XYZ, any solution is taking, and sulfuric acid is added into it. So sulfuric acid is a source of sulfate. So if sulfuric acid is added into it, and as a result of that white precipitate are formed, it means that the that X was barium. And so if barium nitrate is added to X and white precipitates are formed, then X is sulfate. That's why barium has reacted with sulfate to form white precipitates of barium sulfate. So it can be either we can be asked regarding barium from sulfate, or we can be asked regarding sulfate from barium. Okay, so it can be one way or the other. So this is one of the things which you should know regarding the identification of ions. Okay, so this is now again and again I'm on the same page. Okay, guys, look at here. So it is now carbonate. So for carbonate, this is the test. For chlorides, I am telling it to you again and again that these are called as the halide ions. This is the test for nitrate, and this is the test for sulfate, and this is the test for sulfite. Okay, guys, let's discuss about sulfite. Small volume of acidified potassium manganate is added. Acidified potassium manganate changes color from purple to colorless. So basically when acidified, so when something acidic is added to it, let's say we have added HCl or HNO3 into it, obviously for sulfate or sulfite we cannot add sulfuric acid. Please be careful. For Cl1 minus we cannot add a hydrochloric acid, so please be careful about that. Okay, so now when we are going to add these any of the acid to this, they are saying na acidified potassium manganate, or as a result of that, what will be produced? SO2 gas will be produced, which is a reducing agent. Okay, so potassium manganate, that is called KMNO4. I'm writing the formula. KMNO4 is an oxidizing agent. It changes its color in the presence of reducing agent only, and sulfur dioxide is a reducing agent. Okay, now, when acid will be added to sulfite, SO3 2 minus, as a result of that, sulfur dioxide gas will be produced, which will turn the color of KMNO4 from purple to colorless. So this is how we are practicing the reactions for this. So here, potassium manganate, and if from sulfur dioxide produced from sulfite, we can detect the KMNO4, and from KMNO4 we can detect the SO3 2 minus. So it is a two-way, you may say, two-way we can be asked. Okay, so sulfate test I have explained you on the page as well regarding barium nitrate and nitric acid. And now I'm sharing some notes about nitrate. Guys, look at here about nitrates. You can see this thing that nitrate has a formula of NO3 1 minus, and it can be tested with aluminum foil and NaOH and heat. Okay, So we have to do this whole thing, and when we are going to heat it, okay, so when we are going to heat it, as a result of that, what gas will be formed? Ammonia gas will be formed, okay, and ammonia gas will turn red litmus paper blue. So this is how we are going to perform the test for nitrate. So here in this case, they can ask us that can we detect nitrate by adding sodium hydroxide? Yes. Can we detect sodium hydroxide by adding nitrate as well? Yes. So it is basically a two-way traffic. Okay, so this I am trying to explain you again and again, that this is a two-way process. Okay, from one we can find out the other, from the other we can find out the one. Okay, so now come to the next sheet, and here, okay, all right. So here we are done with the discussion about the cations. Similarly, for the anions, similarly for the cations, you can see this thing that aluminum is there, ammonium is there. Obviously, ammonium cannot be detected with aqueous ammonia. So we can say this thing that aluminum and sodium hydroxide, excess of sodium hydroxide is added. So initially, smaller amount is added and white precipitates are formed, and then excess is added and giving a colorless solution. Okay, white precipitates form being insoluble in excess. So when we have added white sodium hydroxide, it has given white precipitates. But when we have added excess of sodium hydroxide, it has given us a colorless solution. When we have added aqueous ammonia, it has given us white precipitate. When we have added excess of aqueous ammonia, it is being insoluble in the excess. Okay. So in the same way, there will be tests for all. Guys, there is a test which is creating a confusion between zinc and aluminum. For aluminum, it is white precipitates soluble in excess. Okay, and for zinc, white precipitate soluble in excess giving colorless solution. OMG, how we can differentiate between the two? Both of them have same type of the test. So if there will be same type of the test, should we say this thing aluminum or zinc? Basically, you can say, but how we can differentiate between the two? So with aluminum, white precipitates insoluble in the excess, and for zinc, it is white precipitates soluble in excess. So zinc is soluble and giving colorless solution in both sides, whereas aluminum is soluble and giving colorless solution in this case only, but not in this case. So please be vigilant about that. And what is the test for Fe2 plus? Fe2 plus is giving you green color precipitates with sodium hydroxide. You can see this thing, and red color precipitates with sodium hydroxide and aqueous ammonia. Both are same, and Fe2 ions are getting brown on exposure to air, whereas Fe3 ions remain same because Fe is not getting it's not changing its charge further. And there is specifically a test for chromium. It has been added recently, not last year, but recently, 2-3 years before. So chromium is giving a gray green precipitates, or you may say yes, green precipitates insoluble in excess, basically. Okay, so green color precipitates insoluble in excess, whereas for aqueous ammonia, gray green precipitates insoluble in excess. So please keep these tests in your mind before solving such type of questions. All right. Okay. Thank you very much, guys. In the next class, inshallah, I'm going to explain these questions based upon this knowledge.